Imagine stepping outside on a clear night. You look up at the familiar silver face of the moon, the only companion Earth has known for over 4 billion years. But then, you notice something else. Another shape, another glow. Earth suddenly has two moons. This isn't just a beautiful sci-fi backdrop. A second moon orbiting our planet would rewrite the rules of physics, climate, biology, and human history. It would turn our predictable world into a beautiful, chaotic masterpiece, or a violent nightmare. Today we're doing a deep dive into the science, geology, and complex consequences of this cosmic what if. How would Earth actually function with two moons? To understand the chaos, we first need to set the scene. How did this new moon get here? Our current moon formed early in Earth's history, likely from a massive collision. For a second moon to join the dance, it would have to either be captured, like a passing asteroid that got caught in Earth's gravity, or formed simultaneously from that same ancient impact, perhaps hiding in a stable Lagrange point, before drifting free billions of years later. For our scenario, let's establish some parameters. We'll call our current moon, Luna, and this new visitor, Secunda. Secunda is about half the size of Luna and orbits at a different distance. This is crucial because orbital mechanics are a delicate balance. If they were too close, their combined gravity might make their orbits unstable, potentially leading to a spectacular collision, or one moon being ejected entirely. The most immediate and dramatic impact of Secunda would be felt on our oceans. As we know, tides are caused by the gravitational pull of the moon, and, to a lesser extent, the sun. The moon effectively pulls the water towards it, creating a tidal bulge. With two moons orbiting at different speeds and distances, our oceans become a complex battleground of competing gravitational forces. Instead of the predictable two high tides and two low tides we experience daily, we would have highly complex, erratic tidal cycles. We have to talk about constructive interference, or super tides. When both Luna and Secunda align, pulling Earth's water in the same direction, their forces combined. High tides wouldn't just be a few feet higher, they would be exponentially larger, surging miles inland. Coastal cities across the globe would face constant destructive flooding. Conversely, we'd also experience destructive interference. When the moons are on opposite sides of the Earth, they would work against each other, partially canceling out tidal forces. This could lead to periods of exceptionally weak tides, where harbors might remain unusually shallow or completely dry for extended periods. The chaos isn't limited to the water. Gravity pulls on everything, including the solid Earth beneath our feet. This constant, uneven tug-of-war on Earth's tectonic plates creates friction deep inside the planet's mantle. This is a process known as tidal heating. Think of the way bending a metal paperclip back and forth creates heat at the joint. Earth's interior would be getting continuously kneaded and squeezed by the shifting gravitational pulls. This increased internal friction generates enormous amounts of heat that must find a way to escape. The result would be a planet that is geologically hyperactive. We would see a dramatic increase in volcanic activity and earthquakes worldwide, similar to how Jupiter's moon Io is constantly churned into a volcanic frenzy by the surrounding gravitational pull. Our relationship with the night would be fundamentally altered. Even if Secunda were smaller, the combined light of two moons would make our nights rarely truly dark. Flashlights would be almost unnecessary in many open areas. Imagine the calendar complexity. Instead of a single monthly cycle, you would have two moons running on different clocks, meaning they would often display different phases simultaneously. You might look up and see one crescent moon and one half moon waxing beside it. Solar eclipses would become a much more frequent phenomenon, potentially occurring multiple times a year. We might even witness a rare and spectacular event, a double eclipse, or mutual occultation. This is when one moon passes directly in front of the other, while both are blocking the sun. Life on Earth has evolved to the predictable rhythms of a single moon. A second moon would throw a wrench in the evolutionary gears. Nocturnal predators that rely on deep darkness to hunt, like owls and cats, would find their strategies compromised by constant moonlight. Conversely, prey species might adapt new camouflage or behavioral patterns to navigate this bright new world. Furthermore, many marine species, like corals and sea turtles, time their reproduction to specific tidal cycles. A chaotic tidal system would force mass migrations or drive thousands of species to extinction, unable to adapt to the constant, intense disruption of coastal habitats. How would humans have adapted to living on a volcanic, flood-prone planet with a bright night sky? Ancient civilizations would have faced a monumental challenge in developing celestial navigation or accurate calendars, as the erratic movements of two moons would have baffled early observers. In the modern era, our architecture would be dictated by the super tides. We would not build major cities on the coast. Humanity would be a predominantly highland-dwelling species, forced inland to escape the erratic surges of the sea. New agricultural methods and resilient infrastructure would be required to survive constant geological and weather instability. A second moon would make our night sky a visual masterpiece, but it would trade Earth's predictability and stability for constant dramatic change. Our tides, our ground, our biological clocks, everything would be vastly more complex and chaotic. We live on a Goldilocks planet where the presence of just one moon at just the right distance created the stable conditions that allowed complex life, including us, to thrive. So next time you look up at that one single familiar moon, maybe be glad she doesn't have a sister. Subscribe for more what-if scenarios. What hypothetical world do you want us to explore next? Let us know in the comments.